Hi everyone, this is a video on elimination reactions. There's two big cases for us to pay attention to, and they both have a couple things in common. They both start with a saturated hydrocarbon, in the one case an alcohol, and in the second case an alkyl halide, and they both end up producing an unsaturated alkene. Here's the first example. An alcohol reacts in the presence of a strong acid catalyst to produce an alkene and water. To do that, we're going to eliminate the hydroxyl from the alcohol as well as a neighboring hydrogen. It's important that we decide which hydrogen to remove, and to do that, we're going to consider the number of carbon-to-carbon bonds. And we're going to remove the hydrogen from the carbon with the more carbon-to-carbon bonds. Let's look at that in action. Here's butan-2-ol. Because it's elimination, we need to pull out the hydroxyl. Take the hydroxyl off. And then we have to make a decision. Is it going to be the hydrogen to the left or the hydrogen to the right? The hydrogen to the left is bonded to this carbon on the end of the chain, which is in turn only attached to one other carbon. It has one carbon-to-carbon bond. The hydrogen to the right, however, is bonded to a carbon which is attached to two other carbons. Two carbon-to-carbon bonds, which is obviously more than one. So we're going to remove that hydrogen. Pull those two out, and we end up producing water, and there it is, HOH. In its place now, we end up forming a double bond. There it is. We went from a saturated alcohol, butan-2-ol, reacted it in the presence of a strong acid catalyst, and produced an alkene, but-2-ene, and also removed some water. The second big case is when an alkyl halide reacts with a strong base, this strange-looking formula, in the presence of ethanol. This is going to produce a salt along with an alkene, as we already mentioned. Here I have bromoethane reacting in the presence of this strong base. What we're going to do then is pull off the H and the Br. We're going to eliminate those two atoms from the compound. The sodium is going to dissociate away from this base, and the sodium and the bromine will form together. Here it is at the very back, sodium bromide, and that is the salt that's produced by this reaction. The hydrogen ended up attaching to where the sodium was, and we eliminated both of those from the compound to produce our alkene, here, ethene. The hallmarks of an elimination reaction are we started from a saturated compound and ended up producing an alkene in the end. And I hope that helps.